Good morning, students. In this lecture 33 of mechanics, we're gonna start our last chapter, that is chapter number 4th, elastic and inelastic collisions. So before discussing the main articles, we will discuss about what is collision, what is scattering, what is reaction, and what are the different types of scattering and reaction. So first, what do you interpret from the word collision? In our daily life, collision means when one object or one particle, it strikes with the another particle. Means there is always the physical contact between the particles during collision in normal life. But in physics, collision doesn't only mean the striking of one particle with another, but actually, it is the interaction between the particles. In physics, collision is termed as the interaction between the two particles, and this interaction, it may be the result of physical contact between the particles, or it can be result from the interaction at a distance. That is, there might be the interaction between the two particles because of the force field. How? As you know that when we have two charges, they are placed at some distance. Suppose there is distance r between them. But as we know that around the charge there is some region which is known as its electric field region, where if you place the second charge in that region, which is not in the physical contact with the first charge, it will experience force because of the first charge. Why? Because this second charge, it is placed in the electric field region of the first charge. So there will be interaction between the two particles even when there is no physical contact between them. Similarly, gravitational force between the two particles or between the two bodies. It is also, there is no physical contact between them, but still there is an interaction between them. So in physics, there might be physical contact and there may not be some physical contact between the particles which are interacting or which are undergoing collision. So next is, what is the difference between scattering and reaction? So first, what is scattering? Scattering is, suppose the two particles, they are undergoing collision. So we will see the nature and the masses of the particles before collision and after collision. And if the masses and the nature of the particles which are taking part in the collision, it remains unchanged even after the collision, then it is known as scattering. So in case of scattering, there is no change in the mass and the nature of the particle after collision. Then what is reaction? In case of reaction, when the two particles, they undergo collision, their mass and nature changes. So if the masses and the nature of the particles change after taking part in the collision, then it is known as reaction. Then the collisions, they are of three types, because the collision can be elastic one, it can be inelastic one. So depending upon that, the collisions, they are of two types, elastic scattering and inelastic scattering. And third one, the collision can be reaction also. So first is elastic scattering. Any collision, it is said to be elastic or it is said to be elastic scattering if the linear momentum and the kinetic energy of the system of two particles, it remains unchanged during collision. Means linear momentum and kinetic energy of the system of two particles before collision and after collision remains same, or you can say that remains conserved. That is known as elastic scattering. And as it is scattering, so masses of the incident particle and target particle. Before collision, the particles, they are known as incident particle and target particle. And after collision, the target particle, it is known as recoil target, and incident particle is known as scattered particle. Why? Because this incident particle, it is scattered after suffering collision with the target particle, and because of collision, target particle, it also changes its place. So that is why it is known as recoil target. So this is the figure. Here this is incident particle of mass m1. It is moving with the speed or velocity u1. Target particle having mass m2. It is moving with the velocity u2. And this is scenario before collision. After collision, what happens? Suppose this incident particle, it gets scattered in this direction. And now its velocity will change. It is v1, but mass is same. And it is scattered through angle alpha with x-axis or with its initial direction. Similarly, target particle, it gets scattered with angle beta in this direction. So this is the scenario after collision. And as I have already told you that linear momentum and energy remains same before collision and after collision. So law of conservation of linear momentum and energy, it will hold good. So this is the law of, according to the law of conservation of linear momentum, this equation will hold. And according to the law of conservation of energy, this equation will hold. Means kinetic energy before collision is equal to kinetic energy after collision. And this is total linear momentum of the system before collision. And it is equal to the total linear momentum of the system of two particles after collision. So this is all about elastic scattering. Then next comes inelastic scattering. In case of inelastic scattering, linear momentum of the system, it remains conserved, but kinetic energy changes. So kinetic energy of the system, it doesn't remain conserved after collision. And as it is a scattering, so masses of the scattered and recoil target remains same as that of incident and target particles. And in case of inelastic scattering, the initial kinetic energy of the system before collision is greater and kinetic energy of the system decreases after collision. So that's why the kinetic energy of the system before collision, it is greater than the kinetic energy of the system after collision. And this decrease in kinetic energy, it appears in the form of heat, it can appear in the form of some other losses of energy. And according to law of conservation of linear momentum, the equation of linear momentum will remain same as that of elastic scattering. And next comes reaction. So in case of reaction, again linear momentum remains conserved, but kinetic energy does not remain conserved. And one more difference from that of inelastic scattering, that is masses in this case, they change. Mass of the incident particle and target particle before collision, it is different from the masses of the recoil target and scattered particle after collision. So here you can see mass of incident particle is m1, mass of target particle is m2, but masses after collision of target particle, which becomes now scattered particle, it is m3, and the mass of the recoil target after collision, it is m4. So this is known as reaction. Now there are two types of coordinate systems in which we will study the collisions or the scattering. First is laboratory system. Second is center of mass system. Now what is laboratory system? Laboratory system means lab system. Sometimes it is also known as lab frame. Actually, it is the coordinate system or the coordinate frame which is fixed with respect to laboratory. So any coordinate system or coordinate frame which we consider in the lab, it is known as laboratory system or lab system. And in this case, we know that any observer, it will be stationary. If it is standing in the lab, it will be stationary with respect to the lab. Any observer, if it is stationary with respect to the lab, and we know that coordinate system is fixed in the lab, it means coordinate system is also stationary with respect to the lab, then this coordinate system, it will also be stationary with respect to the observer. That is why when we consider the collision or when we study the collision in lab system, at that time we always take the target particle at rest. Why? Because that incident particle, it will be moving, but the target particle, it will be placed in the lab. It means this target particle, it will be stationary with respect to the lab. And if target particle is stationary with respect to the lab is stationary with respect to the coordinate system because it is fixed in the lab. Therefore, target particle will be stationary with respect to the coordinate system. And stationary means target particle will be at rest with respect to the coordinate system. So, its initial velocity, that is u2 before collision, will be 0, always in the lab system. So target particle is always at rest in the lab system, and they consider that it is placed at the origin of the lab system or origin of the coordinate system which we have taken in the lab frame. Then next comes center of mass system. As the name indicates, it will be a coordinate frame or the coordinate system which is fixed to the center of the mass of two colliding particles. And we know that if a system, it has more than one particle, then there will be some center of mass of the system. And if we suppose that coordinate system is fixed to the center of mass, then that is known as center of mass system. And we know that we have studied it in the properties of the center of mass, that in the absence of the external forces, we have also proved that center of mass moves with constant velocity. And here, one coordinate system, it is fixed with the center of mass. So if center of mass moves with the constant velocity with respect to observer, which is in the lab system, therefore, the coordinate system, which is the center of mass coordinate system, it will also move with constant velocity with respect to the observer, which is in the lab frame. So now we will study our first main article, which is elastic scattering in lab system or in lab frame or in laboratory frame. So in this article, we will prove that if we consider the collision of two particles, elastic collision of two particles in the lab frame, then after collision, they will move at right angles to each other after the elastic collision. So we will prove this. So this is the two particles. This one is incident particle. Its mass is m1. It is moving with velocity u1 before collision. And as we are considering lab system, so in the lab system, this particle, that is target particle, it always remains at rest. So its u2, initial velocity of this particle before collision, will be 0. And when this is approaching this target particle, at this point, they will undergo collision, that is elastic collision. And then this particle, it will be scattered by angle alpha in this direction. After collision, its velocity is v1. And this target particle, it will recoil in this direction. And its velocity is now v2, that is final velocity of the target particle. And it is scattered through angle beta. So now, as we know that in case of elastic scattering, law of conservation of linear momentum and kinetic energy both hold good. So by applying these laws, we will prove that these two particles, they are at right angle to each other after collision. It means what we have to prove is alpha plus beta is equal to 90 degree. So this we have to prove. Now apply the law of conservation of linear momentum. According to the law of conservation of linear momentum, what we will have? m1 u1 vector, that is linear momentum of incident particle before collision plus linear momentum of target particle before collision. u2 is 0. It is equal to m1 v1 vector plus m2 v2 vector. So this equation is m1 u1, it is equal to m1 v1 plus m2 v2. Now, as these u1, v1, v2, these are vectors, it means they will have components along x-axis, y-axis and z-axis. So, write it in the component form. Then, it will be m1 into u1 vector. Any vector, it is equal to the product of its magnitude and its direction, which is given by the unit vector. So, this particle m1, it is moving along positive x-axis. It means its direction is given by plus I cap and its magnitude will be u1. So, this u1 vector, it is equal to u1 into I cap. Then, it is equal to m1 and this v1, it is in xy plane. Neither it is along x-axis nor it is along y-axis. So it is in xy plane. So it will have components along x-axis as well as along y-axis. As we have discussed in our first chapter that the component along x-axis is mostly a cos component, or this vector, it is making an angle with the x-axis. So, the component of this vector along that axis will be a cos component. Any vector which is at some angle, which is making some angle with any axis, then along that axis, the component of that vector will be a cos component. So, the component of v1 along x-axis will be v1 cos alpha. So, m1 v1 cos alpha, it is the component along x-axis, so I cap, plus m1. Now its component along y-axis. Then along y-axis, its component will be sine component. So it will be m1 v1 sine alpha and unit vector along y-axis is j cap. Then plus m2, similarly v2 along x-axis, its component will be v2 cos beta I cap. And along y-axis, now this vector, it is in this direction, in downward direction. So its y component will be along negative y-axis. So it is minus m2 v2 sine beta j cap. Why minus? Because the direction of y component is along negative y-axis, along which the unit vector is minus j cap. So now compare the coefficients of I cap and j cap on both sides. So after comparing the coefficients of I cap and j cap on both sides, we have got these two equations. Suppose it is 1 and this equation is 2. Now we will apply the law of conservation of kinetic energy. So according to law of conservation of kinetic energy before collision will be equal to, that is half m1 u1 square. u2 is 0, so half m2 u2 square will be 0. It is equal to half m1 v1 square plus half m2 v2 square. And suppose this is our equation 3rd. So now suppose that the mass of the two particles, that is incident particle and target particle, it is same and it is equal to m. Then our equation 1 will become this m, this is also m, this is also m. So m on both sides will be cancelled out. So we have u1 is equal to v1 cos alpha plus v2 cos beta. And this is our equation 4th. And when you will put m1, m2 is equal to m here, this equation 2 will become 0 is equal to v1 sine alpha minus v2 sine beta. And suppose this is equation 5th. And from this equation, move this to other side and you will get v1 sine alpha. It is equal to v2 sine beta. And suppose this is our equation 6th. And if put m1 is equal to m and m on both sides, it will be cancelled out. Half on both sides will be cancelled out. And we have from equation 3, we have u1 square is equal to v1 square plus v2 square. And suppose this is our equation 7th. Agar u1 की value So now in equation 6th, we know that we have this v2 sine beta. And what we have to do now, we have to find the velocity after collision. Means what is the relation of v1 with the u1 and what is the relation of v2 with the u2. So here we have v2 sine beta and in equation 4th we have v2 cos beta. So from equation 4th, find the value of v2 cos beta. So from this equation 4th, find the value of v2 cos beta. It will be u1 minus v1 cos alpha. It is equal to v2 cos beta. This is our equation 8th. Now see this equation 6th and 8th. If you will squaring and adding these two equations on right hand side, you will get v2 square common. Sin square beta plus cos square beta will be 1. So you will get the value of v2. So squaring and adding 6th and 8th, you will get v1 square sin square alpha plus its whole square. It will be a minus b whole square. It will be a square plus b square minus 2ab. And it is equal to v2 square. Because it is common and sin square beta plus cos square beta will be 1. And from these two terms, take v1 square common, then sin square alpha plus cos square alpha will be 1. So we have this equation. And suppose this equation is equation 9th. And now we have used these two equations, equation 4th and equation 5th. And we have not used this equation 7th yet. So now watch this, see this equation 7th and equation 9th. On right hand side we have v2. And from equation 7th we can put the value of this v2 square. From equation 7th, what is the value of v2 square? From equation 7th, v2 square is equal to u1 square minus v1 square. And put this in equation 9th here. And you will get v1 square plus u1 square minus 2 u1 v1 cos alpha. It is equal to u1 square minus v1 square. So this u1 square on both sides, it will be cancelled out. And this minus v1 square, move it to this side, it will be v1 square plus this v1 square, it will be 2 v1 square. And move this negative term to this side, it will become positive. So 2 and 2 will be cancelled out. v1 and v1 will be cancelled out. So we have the expression for v1. So v1 is equal to u1 cos alpha. So now we have to find the value of V2. And suppose this is equation 10th. So what we will do now? In this equation, now we have to find the value of V2 in terms of U2. So what we will do? Put this value of V1 in this equation. Put this value in this equation and you will get V2 square. It is equal to U1 square minus, put V1 is equal to U1 cos alpha. So U1 square cos square alpha. Take U1 square common and you have 1 minus cos square alpha. So V2 square, it is equal to U1 square. 1 minus cos square alpha is sin square alpha. So V2 is equal to U1 sin alpha. And this is equation 11th. And now put these two values. This V1 is equal to U1 cos alpha. This V2 is equal to U1 sin alpha in this equation 6th. Why? Because we have to calculate the relation between alpha and beta. So put V1, V2 in this equation. Put equation 10th and 11th in equation 6th. So we have V1 is equal to U1 cos alpha into sin alpha. It is equal to V2 is equal to U1 sin alpha into sin beta. And this sin alpha will be cancelled out. U1 and U1 will be cancelled out. And we have cos alpha, it is equal to sin beta. And we know that cos theta is equal to sin 90 minus theta. Here instead of theta we have alpha. So this implies 90 minus alpha, it is equal to beta. This implies alpha plus beta is equal to 90 degree. And what it means? That after collision, the angle between the scattered particle and recoil target, it is right angle. So it means the two particles, they scattered at right angles to each other after collision. So that is all about elastic scattering in lab system.